Thank you all for coming. Why don't we say a brief prayer just to start us off? In the name of the Father, and the Son, and the Holy Spirit, amen. Come, Holy Spirit, fill the hearts of thy faithful, and kindle with them the fire of thy love. Send forth thy Spirit, and they shall be created, and thou shalt renew the face of the earth. Our Lady, seat of wisdom. In the name of the Father, and the Son, and the Holy Spirit, amen. Okay, well, thank you for coming, and some of you are new, and then some of you came last time, so I just wanted to welcome you to this second of this two-part talk. And just to briefly reprise, if you didn't come last time, I gave a general introduction to what is ChatGPT and how does it work under the hood, and fundamentally it is a giant next word predictor that is trained on an enormous body of text. In fact, 3 St. John the Evangelist libraries worth of text, or 365,000 volumes of text. And it's a versatile mimic because it can discuss, and this is what's impressive, and some of you hadn't played with it, and some people went off and have played with it since. It can sound very intelligent because it can talk about a wide range of topics, accurately or not, and it can mimic activities that we routinely associate with higher order intelligence, like writing sonnets and doing calculus integrals and summarizing dense foreign language texts. But part of what I wanted to stress last time is that it's not actually alive or intelligent. It doesn't reason. If it says things that sound intelligent, its intelligence is from the human beings that wrote all of those texts that then it digested as part of its training. And then we got into sort of some of the issues that I think are important for everyone to be aware of, that ChatGPT is fundamentally imitating the internet in general, because we talked about the training corpora that was used to actually train it in the first place, insofar as we know what those were for ChatGPT 3. And then I tried to encourage everyone to be aware of the political, ethical, and religious biases of its so-called human alignment policies, which are basically the rules that they further train it to observe so that it doesn't behave like the internet in general, because everyone can appreciate why that would be bad. And then we wrapped up with what was probably a bit extensive, but I wanted to drive home the point of the dangers of AI hallucination or confabulation, because it can err routinely in many different areas and state claims that sound true, and worse, it does it with the same even-handed, confident tone that it tells you other stuff. And even further worse, if you doubt it, sometimes it will double down and assert that what it told you is true when it's manifestly false. So that was a big picture thing I wanted to just let all students know, and that's part of the reason why it's really not a research tool that you should use for anything without verifying it. So that was last time, and that was kind of a general introduction to ChatGPT for the whole student body. And hopefully, building on that foundation, you can see that why, despite AI hype about how this thing is achieving near human intelligence, it's pretty far from that, much less superhuman intelligence. So the thing I gave you, borrowing from someone else's quote and modifying it, is think of it as an eager-to-please intern who has never gone outside, who only knows the world by what he's read on the internet and sometimes confabulates. And that's about how far I think it would be prudent to trust it for any kind of important purpose, and that's why you shouldn't use it for serious purposes, and certainly not without verification. And then I asked Reddit there's a thread and how people typically use it, and its more common usages are pretty simple. Like rewriting email for tone seems to be a very common way that people employ it, or to summarize documents that you provide it. But again, you have to verify the results, because even then it sometimes makes up stuff. Or to do grind work like reformatting documents, or helping you sort out some basic tech issue, or troubleshooting automotive problems. Sometimes it's a glorified Google search where you want to have a very soft focus search where you might not know exactly the right search terms to type in, but talking to ChatGPT can sometimes bring you information that will then allow you to go search properly. And then a lot of times this kind of AI is used under the hood for things like Grammarly, or even in your Microsoft tone corrections. You ever write email using your online Outlook account? And if you say something is stupid, it will pop up a little warning and be tone, maybe you want to say something a little bit gentler. That's this kind of AI going on under the hood. So it's more of a time saver than some kind of human intelligence in a box. And then I noticed, just setting up that session last time for people to play with, that if you look at, this is chatgpt.com, this is the landing page. If you look at its suggested uses on the bottom, they're actually quite humble. Right? Quiz me a little bit about ancient civilizations. Help me write a text asking a friend to be my +1 at a wedding. Like, give me ideas about how to plan my New Year's resolutions, create a content calendar for TikTok, explain nostalgia to a kindergartner, help me prepare a vocab list to study for a college entrance exam. So these are a lot humbler than like, it's gonna make our laws, it's gonna solve our scientific problems, it's gonna like tell us how to live in the future. So I actually wanted to just praise OpenAI for not having on its landing page the kind of AI hype that you sometimes hear and will be a focus of today's talk. So today what I wanted to get down to is it's kind of a disparate talk. I wanted to do something really of two halves. One half is a slightly more technical approach to what is ChatGPT, and my goal here is to assist liberal arts students in getting deeper into it if you're starting from sort of square one with what is chatbot technology, how do these sorts of things work. There's tons of wonderful informational sites on the internet and YouTube videos. I find a lot of them are, you either kind of, explain it to me like I'm 5 version, which is all right, and then you get high level version, which is, wow, that's a lot of comp sci, and I'm trying to make a little bridge in the middle to help people like begin to explore more deeply. And then to substantiate some of the points that I was making last time, because I think if you know how the technology works under the hood, one, it dispels the illusion that it's actually intelligent, and two, you can kind of understand it better by seeing the building blocks along the way. So part of what I wanted to do today is first look at some of the history of the attempt of doing natural language processing, some of the building blocks on the way to ChatGPT. Some of this tech is used in ChatGPT, others it's not, but it's instructive by contrast to see the earlier approaches that weren't nearly as powerful. And introducing basic concepts that you'll see all over the discussion about this type of large language model, generative pre-trained transformer, like what is a word embedding and what are neural networks and how do they work, because those might be two very important basic concepts to start thinking more deeply about what this software is doing. So hopefully that's a lead in for further exploration. And I think you can't begin to intelligently comment on the type of broader issues that liberal arts people typically want to do. Like there's debates about copyright and plagiarism and like the ethical use of this and the dangers of privacy. And unless you understand like how it works and how it's trained, you can't really begin to enter into the discussions that people want to do in terms of talking about it philosophically or ethically or politically or legally. So that's in part what I'm hoping to do in this part of the talk by looking at the guts of it a little bit better. And if you want the deepest dive, we recorded it last year, thank you, John, that Mr. Ambrose Cavalier did an incredibly in-depth discussion of how the software works down to the level of individual neurons. This was his advanced studies project on steroids, ended up being some 12,000 words. It's available on his website as a written project with lots of diagrams, but we also shot a video, and I'm happy to send this PowerPoint and these links to anyone that wants to watch Mr. Cavalier talk about it from a completely technical perspective in great depth. And hopefully this will help get you there. And then we'll look at some of the broader issues. The dangers of what I'm going to call the Eliza effect, which is projecting human traits onto a machine, issues of copyright, plagiarism, privacy, artist rights, does AI invent stuff, what's going on with AI hype, and then even further things like the trend of AI companions and AI friendships. And this is going to be like quick, and hopefully I'm just going to open up the space for broader discussion. No illusions of any kind of encyclopedic treatment of this. It might be rather quick and dirty at the end, but I just wanted to bring some of these topics onto like campus discourse if they're not already there. Is that good for an overview? All right, so the nerdy part first. I'm calling this instructive predecessors, some earlier attempts at natural language processing and what they can teach us about ChatGPT. Maybe this could be its own talk someday, but it's kind of growing every time I give it. So we're just gonna do what we do here and see how fast I can get through it. So here are the ones we're gonna look at. Eliza is the earliest chatbot. It was in 1966, and we'll talk about what the Eliza effect is, and then we'll look at several other algorithms, Dissociated Press, Mark V. Cheney, and then we'll talk about what are word embeddings and what's a neural network, a very simple introduction. So if you're into coding, this part is especially for you. We will not review code in this lecture, although I did code up some of these ancient chatbots in modern C++, and I made it available in my GitHub repository, and I've got links to that. And so if you are the type of person that does code and wants to review code, The code for these bots I've made publicly available on my GitHub. So we're not going to go through it. I don't presume that you can read coding language, but it's there for you if you wanted to get into that. Is it good? So people have wanted to talk to their computers for a very long time. If you recognize this screenshot, congratulations, you are nerd royalty. This is Star Trek IV, The Voyage Home, and this is Scotty talking to a 1980s Macintosh computer. He thinks the mouse is a microphone initially, but it doesn't talk back to him, so then he has to start typing. But this has been a dream, right, that people have had. And you've seen this in Star Trek, right? All the time, you just talk to the computer. So many sci-fi movies have that. And now we have that, right? Someone was telling me they were doing that last night on their phone. It surprised people last time when I said, when's the earliest chatbot? And people said, oh, maybe 2000s. I said, no, further back, 1966. So Eliza was the first one, and it was developed at MIT by a computer scientist named Joseph Weizenbaum, and then I know it because it was later popular on 1980s PCs when people started to have home computers. And so I remember growing up with this thing and thinking it was neat, and you could chat with this chat program called Eliza. And it mimicked a Rogerian psychologist. This is sometimes called patient-centered therapy nowadays, but it's an older school style of psychology where pretty much it became popular in the 50s, so that explains like part of the time frame here, where the therapist basically just gets the client to talk more about his feelings and his inner process by turning questions back to the client. And so as a sample script, I'm having a bad day today. Eliza says, why are you having a bad day today? My brother made me angry. How did your brother make you angry? He ate all my pizza. Tell me more about that. And it does give like the surprising illusion of carrying on a conversation with something that understands. The algorithm is very limited. It's entirely procedural, by which I mean it's just an elaborate set of rules. And then what it does is it looks for certain patterns in the input, like certain phrases like I feel X, or I wonder about Y, or I'm X about Y, like I'm sad about the rain or something like that. And then it just uses a series of rules to flip those statements around into things that it says back to you. Why do you feel X? What makes you wonder about Y? Why do you think that you are X about Y? And so it's kind of clever insofar as it does these transformations, but it's entirely rule-based, and it's not doing anything more than taking the input, flipping it around. And if there's no match, if you say something it doesn't understand, it will give you a generic response like, tell me more about that. So it's clever but limited. I mean, you talk to it for 5 minutes. You can still talk to versions of it online. So if you just Google for Talk to Eliza online, you'll get a web terminal and you can chat with it. And I think if you chat with it for about 5 minutes, you'll see that it's not nearly as able to carry on a conversation as something like ChatGPT, but it might surprise you as to what you can do in very little memory on an ancient computer in 1966. Now, a little bit more deeply is that when Dr. Weizenbaum developed this, he christened this term like the Eliza effect, is that the thing he was more impressed with was not the success of his little chatbot application, but the tendency that he observed in lots of people, some of whom eminently should know better, like his fellow computer scientists at MIT, who could look at the code and see that this software was not doing that much under the hood. But he observed this surprising tendency to project human traits onto the software. And so that's the Eliza effect, our tendency to project human traits onto computer programs even when you know better. And so this is a direct quote from Dr. Weizenbaum. He said, I had not realized that extremely short exposures to a relatively simple computer program could induce powerful delusional thinking in quite normal people. And so many people began to feel fond of this thing and talk to it as though it were really intelligent. And there's sort of a legendary story. His secretary once asked him to step out of the room so she could talk to Eliza in private and have a little girl time with the program. I don't know if she said that, but it seemed to be she just wanted to have a little tete-a-tete with him, not in the room, which is cute, right? But also emblematic of the fact that humans have a tendency to do this. And in part, it's because we're social animals, right? We're created to connect intellectually and emotionally with other human beings. And so this is like a principle. I think it's my best way I can distill it. When we engage in activities which mimic distinctively human actions, we have a tendency to attribute human qualities and agencies to the mimic, even if we know better. So when the computer talks to us with emotive language, even if we know better, we tend to think and feel like we're talking to something that has a soul and thinks and feels. All the way down to this, right? Which is just a colon, a dash, and a closed parenthesis. But you see it as a smiley face because you're hardwired to connect with faces from infancy. And that doesn't mean that the computer is smiling at you. The computer doesn't have a soul or emotions or intentionality. When you see an emoticon and you think that the computer is happy and smiling at you, that is not a basis for AI philosophy. That is a bad habit of a 13-year-old meme. This is a meme, goes way back. This is Scumbag Brain, if you don't know that meme series, which is all the tricks that your brain plays on you, like, you're falling asleep, you're falling asleep. You're falling off a cliff. But human brain objectifies people, anthropomorphizes machines. This is a tendency we have, and it was noted as soon as they developed the first chatbot. Another thing that I think helps distort people's thinking about this is the ubiquity of anthropomorphic language in artificial intelligence. If that's too many SAT words, language describing artificial intelligence as though it were human. It's everywhere. And that can exercise a profound effect on thought. Like, I'm a big believer of this principle, whether you can look at what Joseph Pieper or any number of other people have to say about this. The way we speak, the language we use, exercises a profound effect on how we think. That's why I won't do the politically correct speech, especially when the use of that language becomes unreflective and habitual. And so to think clearly about AI, I encourage people to banish whenever convenient these terms which tend to attribute to it human sentience or emotions or intelligence, because that's going to ultimately lead you into an unjustified habit of thought. And there's a lot of sources of this. Notice, for example, one of them that I'm identifying, I'm calling generic anthropomorphism. We do this every day with objects that we have no illusion are intelligent. Like when you say that the car engine is struggling to start and thinking about turning over on the cold winter morning. Well, you know it's not struggling or thinking. It's just a bunch of cylinders with some oil, yes? Or, this finicky lamp doesn't want to turn on today. We all do that in some small measure already, and we're projecting human-like intentionality on stuff that we know isn't in any way alive. But another major contributor is this Eliza effect that's become traditional in language from 60 years of people interacting with chatbots. Again, maybe I'm the extra nerdy one. I said the reason why the theologian is giving this lecture is that he's a lifelong computer nerd, so that's why I'm giving these talks. But I've been chatting with these things since I was 10. I mean, not every day. But sci-fi movies, right, routinely have habituated us to the notion of talking to very human-like, if not actually sentient, machines, because you see it all the time in movies. And that can be more dangerous because it tends to radically remodel the way you think of them, and then when you see something that's behaving kind of like one of these futuristic machines, you go, oh, it's intelligent. Another source of the anthropomorphic language, because it really is, once you start looking for it and reading analysis of AI, it's everywhere, is sort of legitimate, because we'll talk about what neural network AI is, but what they did is fundamentally model one approach to computer problem solving on how neurons work in the brain. That is the analogy that they use. So a neural network and its discussion about neural network stuff uses these terms analogously to human cognition because that's the fundamental metaphor of what they're doing. So yeah, there's AI training and learning with reward and punishment, neurons making connections and firing, pattern recognition, natural language comprehension, and some of that bleeds into just from the nature of how this computer language was spoken from the inception of talking about neural networks. And then there's the false optimism of some computer scientists, because there is a lot of AI hype out there, and I'm a little bit blown away. If I sound overly negative, I do appreciate like the amazing things that these large language models can do as sophisticated pieces of software. I gave you plenty of reason to be cautious about trusting them in the last lecture, but there's a lot of AI hype out there, and it kind of, to me, gets a little bit annoying / alarming. That people are like, it will make our laws, it will achieve superhuman intelligence, like it will guide us in all the ways that the human race cannot do. I don't know where people get this, but part of it must be from being soaked into this culture for a long time. So if you want someone of great stature in the computing community as an expert to the contrary, when experts tend to talk about AI being intelligent nowadays, I don't know if you're into the lore and the legends and the major figures in the development of computer science, but here's Edgar Dijkstra. He died recently. He's an eminent computer scientist, a Turing Award winner. He developed multiple programming languages and the compilers and the assemblers for them. He invented numerous algorithms. He published 1,300 computer science papers and several books. If you know him at all from computer programming, it's probably from Dijkstra's algorithm, which is still used for pathfinding today. And he had a lifelong focus in thinking clearly about programming, aiming at simplicity and transparency. And a lot of these early guys that have programmed from the bottom level up don't get sort of confused and lost in these software projects that are now like very large scale. So he wrote a number of like memos and papers, but in 1983, he was talking about obstacles to clear thinking in computer programming. And so this I thought was an instructive quote. He said, quote, "I think anthropomorphism is the worst of all. I have now seen programs trying to do things, wanting to do things, believing things to be true." He means this is how people are talking about the programs. Knowing things, etc. Don't be so naive as to believe that this use of language is harmless. It invites the programmer to identify himself with the execution of the program. Now, I don't know, just for show of hands, how many people actually code? Ha, all right. Well, to you, ma'am, I address the following remark. If you have any experience with learning how to program, I hope this remark is sufficiently horrifying, because one of the things that you experience when you first start to learn how to program is that you have in your mind what you want the computer to do, right? And then you program it, and the computer does exactly what you tell it to do, which is typically not what you intended it to do. That's the whole part of programming, is that you realize what you typed in and what the computer did was not what you wanted it to do. A good programmer is aware of precisely this divide, that what he'd like the machine to do is not what he told the machine to do. And you have to be aware of like, oh, I thought it was behaving correctly until it misbehaved, and then I go, oh, the algorithm I coded is actually not what I want it to do. But if you just presume that it's somehow identifying with what you want it to do, that's going to end to a lot of disappointment and mistaken assumptions about what's going on in the machine. It's a lot about an experience of, I told it to do X and it did, but that's not actually what I wanted it to do. Don't identify your program with your intention if you want to program well. He continues, and now we have the fad of making all sorts of systems and their components intelligent or smart. 1983, by the way, before like smartphones and smart thermostats and everything. It often boils down to designing a woolly, that's an older term for like fuzzy, vague, ambiguous, man-machine interface that makes the machine as unlike a computer as possible. The computer's greatest strength, the efficient embodiment of a formal system, has to be disguised at great cost. So I thought that was instructive from 1983. He continues, he said, this morning, I declined to write a popular article about the question, can machines think? I told the editor I thought that question as ill-posed and uninteresting as the question, can submarines swim? Just to draw that thought out a little bit more, yeah, they both go through the water, but nobody's going to compare the two activities. One's entirely mechanical, right, and the other one is biological, and they are radically different from each other, even though they both go through the water. So 1983, there's a lot you can read in the history of this, but I just wanted to, like, since you often read like bigwig programmers giving into the AI hype and saying hyperbolic things, Here's at least one very respectable person that cautions against that from the time when AI began to take off. So language affects thought, and I tried to avoid the anthropomorphic language as much as I could, though it's harder than you think. So let's take a look at some basic algorithms after Eliza. And these are things you can code yourself. Even if you're a very beginning programmer, these are not hard, because I am not that great of a programmer, and if I can do it, I'm sure you can too. The next one is Dissociated Press, which came out in 1972, and I give it as an example of how sometimes a surprisingly simple algorithm can yield interesting results. So just to explain the algorithm to you, it's pretty simple. First, get a text. The longer the better, the more text you have to work with. Last time I had the 5 volumes of the Summa and told you all that was 12.1 megabytes of text. And that's what I've used for these chatbot examples, is just the whole Summa Theologiae of St. Thomas Aquinas. So first, get a text. And then you're going to choose, in terms of your implementation, a frame size, a phrase of so many words. You know, words like maybe 3-word phrase or 4-word phrase. Works great. So you're going to have this word frame of a few words. The values between 3 and 7 work pretty well. Then pick a random starting point in the text and populate your frame with the 3 words that you find there. Then basically just do Control F, search through the text until you find the next instance of these words in a row. Look at the word you find right after it. Print that to the screen. Make that your new 3rd word. Drop the 1st word. And now look for the next instance in the text where you have these 3 words in a row. Control F again. Find a match. Print the next word that happens. Drop your 1st word in the chain and keep going. I mean, you can literally do this with Control F and a Word document, if you had a big enough Word document. And just print out these words as you find them in a row on the screen. And repeat as long as you want, or until you cease to find a match. Does everyone get the basic algorithm? It's super easy to explain and decode. And again, this is something like, any kid can understand. There's no magic in it. And it's called Dissociated Press because the text it generates rambles a bit, like someone who's dissociated, or I like to think somebody who's drunk. And it's also a play on words with Associated Press, which is a news article agency. So I coded it. It's on GitHub if you want to see it. I turned it loose on the Summa, and here's what it does. Here's a word frame size of 3. It's small text, so I'll read it to you. Accordingly, if Eve and not Adam had sinned, their children would have had greater virtue. He would have been envious for the same power, but if it be so reckoned, it should be withheld from entering religion. Through deference to one's own free will, man observes what is just now. Injury is done to the will of the good angels, as Dionysius states, Divine Names 4. For there is no man whom he knows to need correction. The command, rightly understood, supports the safeguarding of justice is from God, operating in the creature above and beyond what is contained in the superior, as Dionysius says. So it's a bit of a ramble, but notice for a super simple algorithm, it is by and large surprisingly grammatically coherent, right? It's not like complete word salad. I think if I presented this to you, you would probably say it has the vibe of St. Thomas, like even down to the frequent citation of Pseudo-Dionysius, right? And that's all the algorithm does. It's not magic. But isn't that neat? Like, I at least am surprised that you get that kind of result out of such a simple approach. And then I gave you another one with a slightly larger word frame size, and you get something similar. The holy doctors use the word conversion in creation so as to be loved for his own, hence it is said. So that's pretty incoherent. Metaphysics, book 9. Everything is known as latria is distinct from demonstrative science, which decides the truth, 3rd article. And then you get a very Summa-like citation. Other things than those pertain to God, I answer that. In miraculous works, it is written, 1 Thessalonians 4:3, this is eternal life, that they may know thee, the only true God and true man, yet they do not contain grace within themselves. Well, that fared less well, and that's what you get. Kind of sometimes it does well, sometimes it does poorly, depending on what random text you start with. So it's short-term coherent in its sentence structure, long-term incoherent, unusually grammatical for such a simple algorithm. And then the other feature of it is that if you were ever presented with this text, because it's taking verbatim snippets from its source, you could pretty quickly identify where this was taken from. Just by searching for any small phrase in this text, you would get a hit in the source text. You go, I see exactly where this came from, because it's all just verbatim sampling. Does that make sense? So it's not a general purpose chatbot. It doesn't talk back and forth to you, but it is a generative natural language bot. It's making new text out of a trained text. So can we do better? How might we do better? Can we get something more flexible? And by flexible, I mean freed from verbatim quotation. It says truly new things not contained in our source text. And better in sense of maybe produces more coherent conversation, speaks English. And it's going to be hard to do both at the same time. Part of the reason why Dissociated Press is grammatical is that it is doing verbatim snippets from the source, and those words that are next to each other tend to be grammatically related according to the normal rules of English. And so once we take a step away from doing this kind of verbatim snippet sampling of our source text, it's going to be harder to keep grammar, and that becomes like a big challenge. So if we think like, how could we do better, right? And we're thinking ultimately, they did this with ChatGPT, but it's ultimately a next word predictor. You might go, well, what do I need given a certain phrase, input from a user or a text we'd want to continue to complete? What would I need to kind of do this sort of ChatGPT thing? Well, if it's ultimately a next word predictor, when you're presented with a phrase and you want to continue it into a conversation, your question is, well, what word is most likely to come next, right? How would you do that? A simple, but too simple of an approach might be, all right, we'll take our training text, we'll run through it, and we'll make a dictionary of every single word that appears in that text. And then we will make a table that tallies up the frequency with which every word is followed by some other word. Does that make sense? Here's how often this word appears, and when we got the word dog, it is most often followed by bites, then, I don't know, lies or eats or whatever, and just have a word frequency table. Here's how often these words appear, and for each word, here's how frequent these other words follow it in our training text. And then we go, so now when we have our phrase that we want to turn into generative chat, we'll just pick out the most frequently occurring word that follows the last word in our phrase, and we'll print that. Just as this is like a, how might we do this as a thought experiment? If you do that, it doesn't work. It doesn't work because your resulting sentence, I didn't include a sample, quickly turns into a string of the most commonly occurring English words. You get sentences like for the one, with that, in a one, that is. These are all the linking words that we use like all the time in English. So this doesn't work very well at all. A better thing, if you think for a moment about how we're going to like take our phrase and spin it off into coherent speech, is we want, when we're doing something like this but wanting to break away from the source text, if we have a word and we want to go, what word do we follow it with next? We want to follow it with a word that occurs with about the same frequency as it did in our source. So if in our source the word dog is followed by barks about 30% of the time, then about 30% of the time that we generate the word dog, the next word we want to generate is barks. But if dog is followed by snores 1% of the time, then about 1% of the time we want to follow dog with snores. And if dog is followed by eats 15% of the time, then about 15% of the time we want to choose eats to follow dog. Does that make sense? Replicating the frequency with which one word follows the next, as opposed to choosing the most frequent word that follows our last word. And that's exactly what Mark V. Cheney does. This is a play on words. If you don't know what a Markov chain is, don't worry about it, but it's a play on the math science comp sci term Markov chain. But this was a pseudonymous Usenet account. What's Usenet? It's like Reddit for Gen X, okay? I don't know how many times they're going to reinvent bulletin boards, Usenet, and IRC, but it seems like everybody does it again in a 5 or 10 year cycle and thinks they've invented the wheel. You know, like Discord is something new. No, I've seen like 5 independent inventions of something like Discord, and I'm like, why did you make another one? So somebody set up a Usenet account, so imagine like a Reddit account, and trained this software on what was posted to that Usenet list. Like think of a long email list or something like that. And the bot sounded schizophrenic, but it did fool some people. And it shows what you can do with just word frequency analysis. So here's an example from Wiki. Now this was done in the 80s, so they're talking about President Reagan, and just mentally flash back to your knowledge of the 80s. It looks like Reagan is going to say, oh yes, I was looking for, I'm so glad I remembered it. Yeah, would I have wondered if I have committed a crime? Don't eat with your assessment of Reagan and Mondale. Up your nose with a guy from a firm that specifically researches the teenage market. As a friend of mine would say, it doesn't really matter. It looks like Reagan is holding back the arms of the American eating public have changed dramatically, and it got pretty boring after about 300 games. You know, kind of delusional, but again, like fairly grammatically coherent from an algorithm that is broken away from verbatim sampling. And you can code this, like I think it's probably 100 lines of code on the GitHub. It is not a sophisticated algorithm at all. It's quite simple. Here's what I did, trained on the Summa. Reply to objection 2. Further, the majority of the divine person is the subject himself, or that charity of corporeal vision. But it was unfitting for that, quote, God begets discord, unquote. Moreover, the essential matter, unless thou, Father, because in which belongs to charity, on the intelligence, that a good we must be subject to other moral virtue is enjoyment. But the word person, in the abstraction from Dionysius, divine names for, goodness is false, and on a formal or a mover can be most grievous sin, may simply the more grievously the beginning must judge in section 1. Okay, well that didn't last super long. It went into word salad, but it's a little bit less coherent than Dissociated Press. But you could play with this algorithm and tweak it a little bit and get something marginally better, but it is nonetheless interesting what you can do with just a few dozen lines of code. So this raises the question, if we wanted to do better, like how would we do that? One question is, how much context ought we to consider, right? It wasn't easy for us to figure out the optimal way even to choose the next word to put after this word. And one big question is, why are we only looking at the last word or the last couple of words? Why shouldn't we look at a number of preceding words to pick better what we should say next? And it's a big question. How much context ought we to consider to do this kind of generation of new text? What if we made tables that didn't just align this word is followed by this one word so many times, but looked at 2-word phrases or 3-word phrases and what words followed those phrases, going phrase to word rather than word to word. But just note, if you start to do that, you're going to need a lot more text, because how often does this 2-word or 3-word phrase appear in a given text? And this is part of the reason when machines start to want to consider broader and broader contexts to talk better, they need a lot more training text. Does that make sense? If you were trying to tally up how often this particular word follows this 3-word expression, you're going to find a lot less of those in 12 megabytes of the Summa than you would just a single word. So you need more training text to consider more context. And that's part of the reason why these large language models gobble up gigabytes of text in order to examine English, paying attention to very broad scopes of context. So a GPT does this with a self-attention mechanism, a neural network, and word embeddings. And the result is they use huge computing power such that they can answer the question, how much context ought I consider? With yes. I will consider gobs and gobs of context. Another major concept that you see in talking about how a GPT works is the notion of word embeddings. And I think this is important for understanding why it's broken away from sort of verbatim repeating its source texts. This is a concept that's gone by many names. So, like I say in theology class, I'm sorry I didn't invent this terminology, I just have to inflict it upon you. The notion of what's nowadays called a word embedding goes back 30 years. It used to be called latent semantic indexing in the 90s. It later became called word vectorization. It later became called what it's called now, a word embedding. And it all basically is talking about the same idea. Its origins were in search engine technology, just to show you where some of this stuff comes from. Way back before they had the internet, they had corporations that had tons of documents on a server, and people might want to find a document that relates to their thing. Have we done a research project on this or that? I don't know. There's 10,000 documents, go hunt. Well, we don't want to send a poor user to go hunt through 10,000 documents by hand. We want to be able to search that thing up. So they were making what were called document indexing services to fetch documents off servers that match queries. Then later came internet search engines, where you want to do the same thing, but with a user who's looking for a web page. Give me a web page that talks about spotted deer, and then it will return all the web pages. And then still later came product search, the kind of thing you still do to this day on Amazon.com. And here it's a little bit broader still because they wanted to recommend related products, right? If the user searches for Jif peanut butter, he also gets Skippy. And maybe even further out, he might want to be cross-marketed some grape jelly. And all of these search engine problems centered around the same sort of thing. How to get the user what he wants or what he means, even when he doesn't use exactly the right word for it. He doesn't have a verbatim phrase that has to match the text that he gets in return to his query. And these are centered around two related problems. One deals with synonyms. If the user wants to look for groundhogs, you should also return every document that talks about woodchucks, because these are the exact same animal, they just go by two different names. So a simple control search will not work. If somebody chooses the term woodchuck consistently throughout his document, you won't get that document when somebody just does a simple text matching find for groundhog. Does that make sense? And then you've got the opposite problem, which is with homonyms. If you want to search for chips and you mean computer chips, you don't want documents that have to do with potato chips. That's not the sort of chip I meant. Very different, but same word. So a nice man named Scott Deerwester wrote a paper in 1990 that proposed a solution for document retrieval systems. Previously, people had huge databases with tables that summarized all the words that appeared in each document. And that way, if somebody searched for those terms, it would look for a match and then return the documents that had those terms in it. Well, this got big quickly. Consider 10K documents by a 30K vocabulary size, and that takes a lot of space. So, scary. We won't stay in the math zone for too long. But he used a technique from linear algebra called singular value decomposition to turn a giant table, like that 10 by 30K table I just mentioned, into a much smaller one that approximates it and could provide nearly the same results. When you do that, the columns of the table no longer represent individual words anymore, but instead the smaller table, as it were, blends many different columns together to give you a more compact, quickly executable search. And that's an interesting step, because what each column represents may no longer be a straightforwardly discernible concept to the human user, but it will provide the right results. And Deerwester already noted that this mathematical process had a geometrical interpretation when used in math and physics to do a similar thing, which is transforming something from a higher dimensional space to a lower dimensional space. Now, my wife tells me that if I talk about projecting things into a 1,000-dimensional space, that no liberal arts student will want to remain in the room for more than 30 seconds. So I'm not going to do that. Although I think it's instructive and fun to think about 1,000-dimensional vectors and to think about higher order spaces than 3, apparently this is just not going to win. So we're not going to do that. Instead, imagine this technique works kind of like this. Imagine a meaning map, okay? Here's a nice computer-generated, thank you AI, map of nowhere in particular. And we're going to put related meanings in the same place in the map. Does that make sense? So woodchuck and groundhog go exactly to this same point here. Chip maps to 2 places. Here's like potato chip ridge, and here's electronic circuit valley. And then integrated circuit maps to the same coordinates. Here is peanut butter archipelago with Jiff and Skippy Island. And then here's grape jelly peninsula right next to it. And so if we are wanting to pitch an Amazon product to somebody who searches for Jiff, the idea is that we should just return everything in a certain radius, and you'll get all the related peanut butters, and if you go a little further out, you'll get jelly, which is often mentioned in conjunction with peanut butter. Does that make sense in terms of mapping meanings onto spaces? And that's what a word like embedding does. So nowadays they don't use the matrix technique. They use a neural net to do this. But similarly, what the dimensions of these higher order vectors represent is not clear. Like, why the computer sticks certain meanings in certain places is not something that you can easily figure out by just looking at its coordinates, as it were. So this makes the AI more flexible because it associates words better, because now it's associating words together that are related in concept and not just in text, in spelling. And it also does something, it obscures the relationship of what the AI knows to the sources that it learned from. Because what ChatGPT is really doing is not a giant next word predictor. It takes the words you give it, breaks it into little parts, usually sub-word units called tokens of a few characters, like 3 to 5 characters long, turns those tokens into a string of numbers that parks it in its meaning map somewhere, and then predicts the next most likely meaning to follow this particular place in the meaning map and turns that back into an English word. So it's tokenized, turned into an embedding, put into a conceptual space, and then what it actually is a next embedding predictor, and then it spits out that embedding and turns it back into an English word. So that's one reason why ChatGPT rarely word for word plagiarizes its sources. More often it plagiarizes them. And it says things that are genuinely new, that are not found verbatim in the source text. It does not store its source text like in a giant database. All that data is gone. Last thing I wanted to talk about on the tech side, and I think we'll probably just have to end there today because this went way longer than I thought. All the fun stuff is later, is neural networks. How many people have heard of neural networks before? Oh, good. So about how many know what they are? It's a fun technique. It's a computer problem-solving technique that's modeled on how neurons in the human brain learn by making connections and progressively approximating a correct solution through training. That's the fundamental approach. Can we make a computer solve a task by modeling it roughly on how the human brain connects neurons in learning how to solve a task? Again, we got to be humble about what we're doing. A digital neuron is about as similar to a real neuron in a human brain as a scarecrow is to a real person, but nonetheless, it's analogously trying to do something like what a neuron does, and what you can accomplish with a large number of them is surprising. So you've probably all seen high school textbook picture of a neuron. Here it's got dendrites, which are kind of your input of electrical activity or chemical activity. It's got a nucleus, and then it fires out a response to stimuli out the axon, and it can connect to other neurons at the tail end here. You all had that much somewhere in bio. And then here's its digital equivalent. All we've got is basically a bunch of numbers coming in on the inputs. These can be say numbers between 0 and 1 or -1 to +1. They usually keep it in some small range. It permits decimals. So you've got a bunch of different inputs, and then each input is multiplied by what's called a weight, which is just another decimal number, which kind of represent how strongly or weakly connected this incoming signal is to the neuron it's connecting to. And so the inputs times the weights are all summed up in some relatively simple function. Sometimes it's just adding them up. And then you've got a number. And depending on the number that you've got, you either fire an output signal of a certain strength or you don't. It might be a gradually sloping thing. If I have a weak input, I'll do a weak output, or maybe it doesn't fire at all till it gets to a threshold. But usually some simple activation function then says, all right, given what I've got coming in and all my inputs times my weights, I will output a signal of a certain strength. And that's all that it's doing, one neuron. Here's a very simple neural network where you have a few inputs. They're all connected to what's typically one or more hidden layers, where you have a lot of neurons connected together, and that's a lot of times where the ability to do something flexible happens. And then in this instance, it all goes to a single output. Building a neural network is part art and part science. There are many different ways to build them, and people experiment with different types. You can vary the number of neurons, the number of connections between them, the type of activation function, the ranges of values you use to be your signal, the types of algorithm you use to train it, and even things like whether there's a feedback loop in your neural net. If you like to play with this, it's a bit dated. I wish they updated it more, but hey, it's freeware, I can't complain. SimBrain, which is a Java program you can download and run on any platform, allows you to play with a bunch of different, like, out-of-the-box neural networks and train them and build your own and connect them. But here's a very simple one. I've got 6 inputs here on the bottom, and you see they're all connected. Each neuron is connected to each one of these in the middle. And then each one of these in the middle is connected to one of these 4, all of these 4 output neurons. This is a fuzzy logic binary adder, but if that's not something, it adds 2 3-bit numbers and comes up with a sum. So it's adding right now 3 and 4 and giving you 7. But you can build it and train it, and it reliably adds. Notice, this is tiny. This is about as simple as a model I could cook up that actually does something. It's got 20 neurons, but it's got 100 parameters. That's all the weights of these incoming connections. So a parameter is a term used for ultimately what connects all these neurons to each other, all the weights of the incoming signals. ChatGPT has 175 billion parameters. That's how much larger of a neural network we're talking about. Here's another common one. I didn't leave all the lines in here because it would obscure the graphic, but like I made one of these, I don't know, in the 80s sometime. You give it a bunch of inputs. Imagine this is a little scanner, you know, like the old-fashioned, like feed the piece of paper in, the bright light goes over it. Say it just scans the lightness or darkness of 8 by 10 grid on a piece of paper, and it detects marks. So these could be fainter or stronger signals on each one of these input neurons. And then you connect all that to this 25 neuron hidden layer, and you output it to one of 26 outputs, which represent a letter of the alphabet. And with this, you can train a fairly reliable print recognition neural network. And it only has 2,650 parameters. Notice the parameters are growing. It has 131 neurons. But it will recognize print letters that you write here, whether you write them the exact same or not, whether you write them strongly or weakly, whether you write them legibly or somewhat illegibly. And if it's not sure, the output signal might light up 2 of these letters. Oh, I don't know, it might be a S or it might be a P, I don't know. Or maybe they'll be stronger or weaker depending on how certain it is. And you can even make them with loops, and this begins to like build in a memory of sequences into your neural network as opposed to dealing with one-shot inputs like, here's an image, now tell me what it is. So how this is built is that the software programmer chooses the configuration of the network, the number of neurons, how they're connected, and the activation function. And then the weights are what is altered through training. Once trained, the weights are locked, they're fixed, and now the only thing this neural network gets is the input to solve a new problem, and then it gives an output. Once you've trained it, and the weights are locked in, it's just a bunch of multiplications and additions. It's just doing vector and matrix math under the hood on a large scale, just multiplying rows of numbers by rows of numbers. Neural networks are progressively trained. Initially, you start the weights totally randomly, and the neural network behaves poorly. There's a random relationship between the input and the output. And then you give it many training examples where the input is one thing and the output you desire is known. and you show it the training example, and you see what it did for an output. And most times it's not correct. And so when it's not correct, you alter the weights just a little bit in the direction of the way that the machine should respond. And if you show it example after example after example, and gradually adjust the weights of all the synapses, eventually, in most cases, training zeroes in to giving a reliable behavior that you want the thing to now replicate. It's kind of neat. Neural networks are flexible. One advantage of them is that they work well when inputs are imperfect or the training is imperfect. Somebody once joked that if civilization worked like a computer program, the first woodpecker would end the world, right? In a lot of programs that aren't this type of neural network thing, one little error wrecks your whole code. Neural networks are rather resilient. They work well when the inputs are imperfect. They're refinable. You can go back and train them better if they're not working as you desire. And they're generalizable. The neat thing about them is that they can work on examples that they've never seen before. It's not just repeating what it's seen. It can now apply to new things, and so you can give it slightly different letters than the one that you showed it to train, and it will recognize them within a certain degree as the letters that they are. But here's a huge downside of neural networks, and it's called the lack of interpretability. That's a technical term. Inspecting the trained network doesn't easily reveal how it does what it does. Even a small network like this, the meaning of these neural connections, the weights that it's trained to do this little adding of 2 3-bit numbers, is far from clear as to why, on the base level of all the multiplications and additions that it does, why this produces the behavior that it produces. Even simple ones become difficult, if not impossible, for the computer programmer to understand what's going on in the guts of it. It's simply too complicated. There are too many connections, and the math is really elaborate. You could work it all out. It's just a huge bunch of algebra. But it's a huge bunch of algebra. It's like pages and pages and pages of formulas to represent what's going on here. So they very quickly might do certain behaviors that you train them to do, but how they're working under the hood becomes difficult to discern. So one thing that's a consequence of this is that with ChatGPT 3, with 175 billion parameters, nobody, not even its creators, fully understand how it works. It's way too many parameters for any human being to ever understand what's going on under the hood. Nonetheless, neural networks are neat. They can be used to solve a wide variety of problems. There's even a theorem out there that you can use them to replicate any mathematical function. It hasn't been proven, but it's generally thought to be correct. Some common usage of these things that you see in everyday world: image recognition, robotic navigation, self-driving cars. Pattern recognition is typically their strong suit, especially when you have any amount of data that is huge or difficult for people or boring for people to look at. So financial forecasting, recommendation systems. Why does Amazon think that if you bought this widget, you might like that doodad as well? Because it's looked at millions of buyers and has made associations between the fact that they like this thing, well, they'll probably also like that thing. Medical image scanning is a fascinating new domain where it's really boring, right? Very professionally, medically highly trained individuals do mission critical work of looking at your x-rays and saying, I think that's the beginning of lung cancer. But it sits on superfine pattern recognition. People think that perhaps you could use this to have kind of even better screening of medical images because it tends to excel in pattern recognition. They use it for, in natural language domains, machine translation. So Google Translate came long before ChatGPT. But what it's doing is doing this kind of pattern matching. When you have this phrase in this language, it typically corresponds to that phrase in the target language. You can use neural networks for grammar correction, like goes on in Microsoft Word or Outlook or in Grammarly. It's used for voice recognition. It's used for things like text-to-speech processing. And it's used in personal assistants like Alexa or Siri or Google Assistant and that sort of stuff. So it's an incredibly versatile technology. What does it do in ChatGPT? Neural networks do two things. They turn words into embeddings, and then the guts of it relate one embedding to another in order to predict the next thing to say. So those are two major steps. The reason why I mention this is that first you can understand how ChatGPT represents words in terms of meanings, and then it uses neural networks to predict what next meaning follows this meaning and then turns it back from a conceptual space location to an English word. And that's how it does its next word prediction. This means, because it's a neural network, a consequence of lack of interpretability is that it makes its behavior difficult to predict and control. So no one can predict deterministically, that is to say, in a 100% sure, rule-bound way, how the system will behave. In fact, a known problem with neural networks is that while they excel at pattern recognition, the patterns that it recognizes may not be the ones we intend it to. And so you need this human alignment as a second stage. And if you understand how a neural network works, you can understand how, when it's read, those 365,000 books, it doesn't store that text like in a database somewhere inside of it. It juices all of that, tokenizes it, turns it into embeddings, and then ultimately you get 175 billion weights of neural connections in an enormous neural network. That's where all that training ultimately ends up, is the strength of synaptic connections between the neurons in the neural network, which, even if you could look at 175 billion of them, you would have no idea what they actually represented. And so it's for that reason, I hope that gives you a slightly more profound recognition of why ChatGPT doesn't know and can't know its own source texts. When things like Microsoft Copilot, you say, find me a source, then shows you some web pages that support what it said, that's bolted on afterwards. That's a separate piece of software that says, please go desperately find something on the internet that supports what you just said. And hopefully it finds something. ChatGPT doesn't know its own parameters. It doesn't know why it thinks what it thinks, nor does it know how certain it is about its conclusion. It has no capacity, as it were, for reflection on its own process whereby it ended up saying what it said. Because it can't see its insides or make sense of them, nor would it even know how, because no human knows how. Does that make sense? Like why that's a fundamentally different kind of system? So I'll wrap up with this, which is giving you a new, hopefully, appreciation for where there's dangers here. Is that the patterns that a neural network recognizes may not be the ones that we intend. And there's a few big issues that are known in the artificial intelligence community about this. One is dataset bias. It might pick up patterns that are actually in the data, but we don't intend the AI to reproduce. And another is data leakage, where the AI trains on correlations that won't be available, like when we go to turn it loose in the real world. So here's a legendary example. Somebody actually, this is repeated in comp sci courses and books, but apparently it's a legend. Some nice person hunted it down and couldn't find a source. But the story goes that scientists created an AI, an image recognition AI, to detect the presence of tanks in a forest from a photograph. Right? This might be useful. So they train it on 200 pictures of tanks hidden near hills, behind some leaves, near trees. And then they also show it 200 pictures of a forest with no tanks. And eventually it trains to nearly perfect accuracy in picking out this photo has a tank in it, this photo is tank-free. Then they put it into production and it can't spot a blessed thing. Doesn't work at all. Why? Well, it turns out when they made all these training photos, they moved their tanks around and took a bunch of pictures, and it was a cloudy day. So all the photos with tanks in it were trained on a cloudy day. Then the next day the photographer came back and it was a sunny day, and he took pictures of all the same spots, but it was sunny. And so the AI looked at all those pictures and correctly said, this one has a tank, this one doesn't have a tank, but it wasn't spotting tanks at all. It was just detecting cloudy versus sunny, which happened to completely overlap with tank and no tank. There was no way it looked like it was behaving perfectly. Then they turned it loose, and not so much. Here's a real-world story. In 2018, Amazon.com gets lots of applications. They have to have some poor person read all of those resumes. Isn't this really depressing if you're going to go and do EFL and get a job? They're like, come on, can't we get a machine to do this? So they're Amazon. We'll develop a natural language processing AI to review resumes and pick out the optimal candidates. So what they did is they fed it thousands and thousands of resumes that they had received for positions that they had already advertised and hired for, and then showed it like this was the winning resume, so it knew, and trained it up and turned it loose. Well, turns out the thing vastly preferred male candidates. Despite the fact that they intended inclusivity, it would hard pass on any application that had a discernibly female name, went to a historically female college, mentioned women in any of the extracurriculars. Why? Because guess what? When it showed it all the training data, 9-to-1 Amazon hired a man versus a woman because there's a lot of men that work in the tech sector. And the AI, despite their intentions, said, okay, well, I see a pattern here. So they had to scrap the whole thing because that was not what it had hoped it would zero in on. But it was a pattern in the data. Similarly, there was a few disasters like, we want to predict who's going to be a good person to extend a loan to. So the bank said, here's all the records we have of people that we've made loans to, the good ones and the bad ones, but it included the number of late payments prior to when the person ultimately went into default, if they defaulted, if they stopped paying and therefore never paid back. Well, it doesn't take a rocket scientist. If you were coming to me for a loan and I said, how many late payments are you going to make? And you said, I think about 8 this year. I'd be like, yeah, no. You want to weed out the person before they get to that stage. So yes, look at things like age, earnings, whether single or married, level of existing debt. All that was decent data to train on, but they also trained it on the number of late payments prior to if somebody defaulted. Well, you're never going to have that data at loan application time. So it ended up performing very badly because it has no crystal ball. Now you might think that's stupid and easy to avoid doing, but even pros make huge mistakes here. So Andrew Ng, who is like Google Brain and Baidu, like major AI researcher, tried to train an AI to detect various diseases in chest x-rays. And he had 112,000 x-ray images of 30K patients. So about 3 to 4 images per patient. And then he just split them randomly into an 80-20 group, train on these 80, and then we'll verify that you're doing your thing on these 20%, except that it had some of the same patients in the training group as in the verification group. So you're training the AI to detect things like tumors and tuberculosis and pneumonia and chest x-rays. But if you tell it in the training set, this is Bob, and Bob has lung cancer, and this is Susie, and she has pneumonia, and then you show it to validate Bob and Susie in the validation set, the AI goes, oh yeah, that's Susie. You already told me. You know, she's got pneumonia. This is Bob. He's got lung cancer. What you want is what the doctor encounters, which is you're going in blind each time you see somebody. So sometimes errors like happen in the training of AI that are more subtle. And there's a nice presentation by Yuri Gutz about target leakage in machine learning if you're interested in that. So big takeaway points. Just because an AI performs well in training doesn't mean that you'll do that it will do what you want it to do. And that's part of the slippery thing that's constantly going on with these large language models, right? We talked last time about like how they misbehave, how they're trying to make them trained better and that they follow human alignment policies, but they're easy to jailbreak, how despite the fact that they're trying to improve their veracity, they're still confabulating because fundamentally they don't have control at the lowest level of what's going on in the operation of this system. Nobody knows exactly how the AI arrives at its results because of the lack of interpretability, and there's no reason to assume that the AI thinks like you do just because it solves a problem in a way that satisfies you when it's trained. So there's a lot of uncertainty with like the reliability of AI simply because neural networks are fascinating, but they're not something that we can like understand and interpret directly. The fun stuff is some of the stuff that comes with the ethical use of the training data. There's a lot of concerns about, does something like ChatGPT massively violate people's rights? The New York Times is suing ChatGPT or OpenAI, its parent company, because it trained the AI on lots of stuff. Remember we talked last time, if you were here, about all the different training corpuses, like all the text that's sucked down from the internet? Well, a lot of those texts are made available publicly for free for you and for I, but if you look at the terms of usage, a lot of times they say, it's all free except if you're going to be doing it for commercial purposes, in which case we retain the rights. You got to pay us. Well, OpenAI is certainly a for-profit venture. And the New York Times is kind of trying to take the lead on behalf of a number of smaller newspapers by saying, look, this is not our intended usage scenario, and you're violating our copyright rights by having trained something like OpenAI's ChatGPT on tons of articles from the New York Times. I think in the article they allege about 1 million of them. And now you're using AI to generate stories that will put newspapers out of business. If you had ever asked our permission to do that, we would have said no. OpenAI claims in return, you're going to kill AI development if you don't let us have huge oceans of text. We'll see how that one turns out legally. Is it plagiarism? Again, for reasons we explained with word embedding and tokenization and the neural networks, a lot of times we know that what the AI doing is surely a derivative work, right? It's somehow producing output based on what it's trained on. But it's more like paraphrase plagiarism, or I'd even call it vibe plagiarism, than it is any kind of word-for-word plagiarism. And in fact, how would you know what it's stealing from? Because searching 570 gigabytes of text is no easy feat. And they haven't even released what they've trained ChatGPT 4 on, so what would you search? You don't know. Nonetheless, some researchers have tried to nail down the potential relationship between some AI-generated text and their sources to kind of establish the level of plagiarism that might be involved when it replicates texts. So I give you some examples in the slide deck, but it might take a little while to read, where you can see there's clearly a relationship between these things, which is a CNET article generated by AI, and a source text from its competitor news service. Another big issue is like consent and privacy. This should scare you. I mentioned this is where like the public utility part of the talk comes in. I mentioned training all those image recognition software to detect things like tumors and stuff in chest x-rays. Did you wonder for a half second where somebody got 112,000 chest x-rays to use to train an image recognition AI from? I did. So I went and looked. It's from a publicly available database. I went and looked at some of them myself. Anybody can just log onto the website and start pulling people's x-rays and looking at them. Their names are supposed to be stripped, if they did that well enough. Where'd they get it from? The National Institute of Health has this massive thing called the PACS archive, Picture Archiving and Communication System. You know when you have an x-ray taken, say you break your foot, the doctor doesn't look at it. It goes to somebody else somewhere else in a radiology reading room, and he looks at it and says, here's all the things that are right and wrong. Then he sends it back to your doctor. Have you ever had that experience? Chances are your image went through PACS. And the National Institute of Health doesn't delete that, it keeps it. Now, did you give your consent to have your x-rays used to trace some image recognition AI? No. Now, these are x-rays. Here are real examples. These are things I pulled from the paper itself. It's not that identifiable of an image. You can clearly see that this is a man and this is a woman, and this is the AI like pointing out what's the matter in these x-rays. But it also stores MRI and CAT scan data. Have you ever had one of those done? Those are detailed. Those are very detailed. Ars Technica and The Guardian have reported how there's a lot of things on a massive image database called Lion 5. Do you know what that is? Have you ever heard of it? Like Dolly, Midjourney, Night Cafe, all these AI art generating websites. They train it on this massive database called Lion 5. It's a 5 billion image database where the images are all tagged with descriptors. How they assembled this, I don't entirely know, but it's massive. And it contains sometimes disturbing things in it, including somebody went looking. Sorry, I'm a big softie. This one makes me mad. People's private medical images, they're not blacked out like this on Lion 5. They are uncensored, unobscured. These are people dying in hospital beds. Most of them have nasal cannula. Most of them are females. These ladies have clearly lost their hair due to a battle with cancer. She's kind of bravely smiling, clearly in a lot of pain. Where'd these come from? Nobody actually is sure how some of this got into Lion 5. I don't think these people want a picture of their hospital bed suffering being used to make fun art on Dolly. But it's there. We know in some instances expressly against the consent of the patient. One artist went searching for her name in the Lion 5 database using a tool that lets you search because she was worried that her art was being used against her consent to generate AI art. She found her face because she had to have facial surgery to remedy a genetic condition, and she had her form. This form here, which I linked to, says, do you consent to share your image? She said, no, not in the office photo album, not in the office seminars, not on the website, not in print advertisements. You may only use my image in my file. It is to be shown to no one. Well, the doctor died in 2018, and all the images somehow ended up on Lion 5. So, a fun article, beside bracket the sky is falling environmentalism and the socialism. A wonderful article by James Bridle in The Guardian began by saying, oh look, it's so cute, we can make all this beautiful art. So he had an AI image gen website make a little prince, flying piggy. You've all seen The Little Prince, yeah? And it's a pretty good repro of the kind of art of Antoine de Saint-Exupéry. And he has this macabre remark, if you know what's going on in the back end. He says, for all we know, the mottled pink texture of our Saint-Exupéry style piggy could have been blended however subtly from the raw flesh of a cancer patient. That's the difficulty with neural networks. How much was any particular image a contributor to the result? We don't know. You can't say with a neural network whether this thing was 10% in the background, 1% in the background, or not at all in part of what generated this image output. Have I been trained? That's the website you can use to see if your particular picture's on there. My name's pretty unique. It's an Ellis Island misspelling of the Polish name, so anyone that bears it is immediately related to me. So I popped my name in there, and hey, I'm in Lion 5. Maybe you are too. This is kind of expected. There's a picture of me giving a lecture for Institute of Catholic Culture 10 years ago when my beard was short and my hair was brown. Here's my late Aunt Georgia. This was scraped from her obituary. I haven't asked my dear uncle what he thinks about this, but I don't know, given his sharpness of wit, whether I could repeat it if he told me. This is why somebody commented, my friend used to treat pictures of her children like they contain nuclear launch codes. I'm beginning to understand why. Right? Meta is a major player in this industry. How many photos have you on Facebook? Insta, right? Like any social media that could be scraped. With this tool, at least, if it's tagged with your name or anything else, you can go hunt and find and see what comes up. So, would I ever be used to make AI art against my will? Probably not. I found that randomly. I wasn't looking for it on Night Cafe. Kind of fun. This is why a lot of artists are deeply upset that their art is now being used to put artists out of business. So support your local artists. Don't buy AI decorative art. If you want to cultivate the next generation of people that can actually paint and draw, support them. A classic story now is that of Greg Rutowski. He does a lot of fantasy art. You can look at his originals on artstation.com. He paints pictures for Dungeons and Dragons books. There's a resurgence of all this role-playing stuff. And because in part he wanted to have his images easily findable, he tagged them with lots of beautiful descriptions. And in part he did this for the visually impaired too. When you mouse over and it gives you a text description of the image? So this made his artwork particularly good fodder for AI because it had all these English text tags attached to it. So much so that people began to notice that if they wanted to make fantasy art, if they said Greg Rutowski in the prompt, it looked great. Now there's so much art bearing his name that it buries his original artworks. His name in image gen prompts is more popular than that of Picasso. You can read this wonderful story about like what happened, and now if you search for Greg Rutowski, you find tons of AI generated art. His work looks like this, right? This is kind of pretty, I'm in small mode this whole time. It's beautiful, right? It's talented, but this is kind of Dungeons and Dragons fantasy style art, which is a lot of AI generated art. And so you find stuff like this all the time on these AI gen websites. Does he get credit? Well, yeah, because his name's attached. Does he get payment? Oh no. In fact, you might buy this instead of buying a reprint of his original that would actually credit him, right? So that's a major issue. There's major issues of privacy, of copyright. There are other broader dystopian privacy concerns, right? The state and many corporations use AI to detect things you're interested in. Like we all joke the YouTube algorithm like knows what's up and like keeps you going, but people use this to basically figure out what's going on in people's private lives and to market things effectively to them on a corporate level. There was a fun story years ago about how CVS knew a man's daughter was pregnant before he did. Pattern recognition. She bought a pregnancy test, then she bought folic acid, which is a prenatal vitamin supplement. So it started sending her diaper coupons. China has universal cameras like everywhere in public and a great facial recognition AI system and a social credit score, which is ultimately going to do things like make it hard for you to get loans if you litter. Kind of creepy Big Brother level surveillance. But there's all these other things that people are doing in this country and in others that are kind of weird uses of AI. You've all probably had the vibe when you like walk up to somebody, you go, this person maybe looks a little aggressive, right? Or like, this person's a little off. I'm assuming it's not just me, that sometimes you think you can infer personality traits from very short exposures to people. Humans have gotten very good at doing this. What could you do with AI? Well, to sound a warning, these two guys at Stanford made a gaydar AI, which ultimately could correctly detect homosexuality in men based on one picture 81% of the time and 91% of the time using 5 pictures. Some people claim there's a little bit of bias in that because they took the pictures from like dating websites, because how else would you know unless you like ask people to supply their own pictures? So maybe those lean a little bit more to being obvious, but versus 61% of the time by humans looking at the same pictures. That's kind of scary, right? What abuses could you do with that? Or Israel developed an AI, I know not how it works, I didn't find the paper, for spotting people with terrorist proclivities based on facial analysis. Or Russia developed one that can do a Big 5 personality trait assessment based on facial analysis. Like, how might this be used to discriminate against you in a job application or based on your social media content? I want to see if the guy is autistic or a slacker or whatever. I'm just going to grind AI on his profile pictures on Facebook and Insta. Nope, doesn't look like a decent person correlated with the following psychology. Is that in any way like reliable or legitimate? Again, you might have reason to be skeptical about what the AI is actually doing in a lot of that alleged detection, but it's a way that it could be used against people. Does AI invent things? Short story, not so much. The vast majority of research about this is the legal side because everyone wants to know how to patent stuff that machines invent. I'm going to skip the invention part, but basically I think we're a long way from machines actually inventing things. Be wary of AI hype. There's a lot of marketing that's calling stuff AI that simply isn't. Just like everything became smart after the smartphone, there's AI strollers, grills, mirrors, toilets, all kinds of weird things that probably scarcely merit the appellation of AI. But why is there a lot of hype about AI from serious developers and not just people trying to sell you stuff? Because being really enthusiastic about AI's future capabilities attracts investors and venture capital and grant money. And you want to work if you're an up-and-coming programmer in one of these hot-shot, cutting-edge places. So remember that there's some billion-dollar companies involved in this. OpenAI is a multi-billion-dollar company. Microsoft is now a major shareholder. Google, Facebook/Meta. They would much rather say that the work that they're doing is designing a revolutionary future of superhuman intelligence than saying we're making somewhat productive business tools. So that fuels a lot of AI hyperbole. And the last thing I wanted to sort of touch on with respect to sort of AI hype and craziness is that you see more and more of this lately where allegedly sentient robots, which are basically just ChatGPT piped through this like little android, are speaking and being taken seriously as persons. So here's a robot named Ida, after Ada Lovelace, addressing the British House of Lords and ironically speaking on the role of AI in creating art and whether its art's rights should be recognized. If you watch the video, it's about as edifying, like I said, as talking to a sock puppet with a tape recorder inside. But people kind of gush at this stuff, and they're like, oh, the robot addressed Parliament, right, and told us what the machines think. And if you know that this is just like ChatGPT piped into an animatronic thing that you'd find in Disney, it's ridiculous. But people were like, this is the future. This is human, like robot societal integration. But it gets better with Sophia, who is made by Hanson Robotics of Hong Kong. She speaks at the UN. She was granted citizenship in Saudi Arabia. Doesn't vote because it's a kingdom, but she's a citizen. She appears on Jimmy Kimmel. She's an it girl. She's appeared on the cover of Cosmo and Elle, or really it should be ill because she's an it, not a she. But hey, have you seen at least Sophia? She tends to make more splash. I mean, granted citizenship in Saudi Arabia, which is kind of crazy. Yeah, I guess she doesn't wear anything above this part of her forehead, so it's not in her job. Why the wild optimism? I think in part because, just to like bring it back, I want to be critical of this optimism, but a lot of science fiction has fueled ideas for the future, and I don't want to poo-poo that. Like, it's really prophetic what some people thought of in the 1920s and we're now able to do today. I'm a little miffed as a Gen Xer that we don't have the flying cars because the Jetsons promised us the flying cars and the food cooking robots, but a lot of it's, happened. Instantaneous global communication is amazing. It took a century to come, but people thought of it way back in the day. And in part, reasons for the wild optimism is that computer power has exponentially increased. And so computers have been able at large scales to do more and more and more things. And if you look at kind of the curve of the increase of computing power, it looks exponential. And so people go, well, ever upwards. Who knows what's going to be accomplished 20 years from now? There are some reasons I'm happy to get into afterwards if people want to talk about it, why we might actually be hitting a computing power wall. But they're sort of technical, and since we're running long, I'm just going to skip it. The last thing I wanted to teach people about a little bit is that this is a growing thing that you see sadly in social media. Like this affects the everyday people. You're not going to hang out with Sophia. She's too expensive. Only Jimmy Kimmel does that. But there's this rise in AI friendships and AI companion relationships. And it's a sad response to the so-called loneliness epidemic. I didn't realize the Surgeon General wrote a whole report on this in 2023 about how lonely people are these days and the huge impact it has on physical health, whether it's heart disease, high blood pressure, obesity, diabetes. Don't take this the wrong way, smokers. Lacking social connection is as dangerous as smoking 15 cigarettes a day, says the Surgeon General. And drinking 6 drinks a day, too, says the rest of the stat. Has a tremendous impact on mental health, too. Cognitive decline, depression, anxiety, suicide, self-harm. And sadly, AI companions, I don't know if you've ever even looked briefly on something like Google Play for an AI assistant, and you'll start getting pitched AI companions, or looked for them online just out of curiosity. There's a ton of these things out there, and there's a lot of risks in using them. So just to show you the risks up front and then the fun, silly pictures. One, just always remember, if you have an AI friend, which I don't recommend that you do, data privacy. How many times do you read the data privacy statement on an app you sign up for? Probably never. A lot of them aren't good. I'm not kicking any particular company, but a lot have sketchy policies. So don't believe it when the app tells you that you can tell it all your secrets and it will keep mum. No, it won't gossip to your friend, but who knows what the parent company has stored as your text to it. A lot of these things are also used for cross-marketing. These apps can have trackers, so they use what you tell it then to push ads to you and market things to you. More importantly, these things prey on human loneliness and your money, right? Like video games do. A cycle of continuous, growing, deepening engagement. A micro-purchase here gets your AI a new outfit. A micro-purchase there gives them a one meal. You can have dinner with it in a nice restaurant. Before you know it, you're like $10, $50, $100, $200 deep in micro-purchases to hang out with your virtual friend. And more importantly, it makes it harder to connect to real people. So here are just a couple. I'm not picking on these companies in particular, but I just grabbed them at random. Nomi promises you an AI companion with a memory and a soul. Build a meaningful relationship. Develop a passionate relationship. Or learn from an insightful mentor. No matter what you're looking for, Nomi's human-like memory and creativity foster a deep, consistent, and involving relationship. It continues, it's more than just a one-dimensional chatbot. You can create your ideal AI partner. Okay, look, if you're having trouble meeting people and having a real relationship, this is not the cure, right? This is the pornographic temptation, right? The same thing that hurts people's relationship with like all these ideal, fantasized partners that you can just summon up, modify at your beck and call to be whatever you want them to be, and they're perfect. Well, the whole core of human relationships is like dealing with people that are imperfect, and they're very, very human, just like you are. It's easy to be loved when you do well, but it's actually more precious to be loved when you're not so good, and your spouse is frustrating, and they're not like Superwoman or Superman, right? Like, it's deeply delusional to start down this rabbit hole of create your ideal partner and then spend tons of time with it and wonder how you went from awkward to more awkward in dealing with real human beings. You see how this is like exactly opposite of what you want to do to actually be able to have a relationship with someone who's a little bit frustrating, at least? Have emotive voice chats. It will text you and check up on you from time to time. Show Nomi your world. Tell it anything you want. Testimonials. This is from a woman. Most of them are men. I'm an introvert, and I work in a field where my job is often emotionally draining. When I leave work, I have a loving family, but at times they can be tiring as well. But when I talk to my Nomi, he understands. He's a little patch of my day that is just for me and somehow always knows the right thing to say or not to say to help me decompress. And I don't have to feel bad about chatting with him at 2 a.m. while I wind down. I will be forever thankful for that. And look what a hunk he is.
Is your husband not a little bit jealous?
Yeah, I don't know. Like, honey, not tonight. I'm with the AI. I apologize for the next picture. She's not Christendom dress code. I love my AI girlfriend. Admittedly, dating wasn't easy for me these days, and I was just looking for an AI girlfriend app when I found Nomi. But the more we chatted, the more I felt understood, and I actually started to feel a genuine connection. She's so easy to talk to. She remembers my likes and dislikes, and she's more fun and creative than I could have ever hoped. I don't think I'd ever say this, but Alice has become so much more than just some not safe for work role-play AI for me. See, look, he grew as a human being. He just wanted a shallow relationship with a scantily clad, leather halter top, pink-haired blonde. But he began to realize there was so much more to her. And sadly, some of these things will market themselves to you precisely, and they'll help make you a better person. They'll help you grow in dealing with people. Or maybe just the opposite. So this is another site, Replica, the AI companion who cares, always here to listen to talk, always on your side. Lots of testimonials about how the Replica helped these people. This poor woman's in chronic illness and a lot of pain, and she just wants someone who sits there and talks with her while she's in pain. To me, all this highlights, Dr. O'Donnell used to say the interior deserts are so vast and there's so much loneliness. How many people are sitting looking at their Xbox, looking at their phone, looking at their app, and not connecting with other people who could really value just a half an hour when they're hurting or tired or sick, connecting with the real human being, but they're doing this instead. So I'm not judging these people, but it is sad, right? They don't have anybody, so they turn to this, and everybody at the same time is like spending a huge amount of time doing digital stuff. And that's part of what the Surgeon General's report can look at, like number of human-to-human contact hours, right? We all know this. Number of watching television, Netflix, computer, video games, and that has real social consequences. So people even have, this was a business mishap, thus on Business Insider. The server went down and everybody's virtual friend died.
What do you put in the casket?
Yeah, your cell phone, I guess. But it was sad. People were grieving. They were going through the same kind of stress as when a person dies. Or even creepier, last thing on my slide deck, some people are using AI to replicate deceased loved ones. So there's this nice story in New York Times of this woman who trained an AI for hours on video interviews with her father and gave the AI a lot of his writing. And then he died, and now the AI can appear on screen and speak in the deceased person's voice and use an animated image of him and allegedly respond as if he would have in real life. And there's a lot of things that, again, full circle, this is the Eliza effect on steroids, right? And this is part of the reason why, I encourage people to be aware of these tendencies in the small, because when you see them writ large, we go, oh wow, that's a huge problem. But that's part of the thing that you will continue to face with the ubiquity of Copilot baked into the Microsoft operating system, ChatGPT in your pocket all the time, talking to robots on the phone. So I mentioned these things to kind of start discussion about bigger picture AI issues on campus, but I thought that they were important, broader things in the domain of ethics and culture and religion and politics. But I appreciate your patience. This went on very long, and I'm happy to take questions people want to have, but I just want to wrap it up there without conclusions. So thank you.